In our research, we have solved 4 problems that form the main challenges of implicit modeling. One of the strengths of using implicit techniques is that blending between objects can be done automatically by simply summing field values and redrawing the isosurface. We present a new family of operators that solves the problems replacing earlier standard blending. In the following video, the examples on the left illustrate the problem, and our solution is shown on the right. With standard blending, 2 cylinders blend at a distance before they come into contact. The second problem is that small features are blurred when a large primitive blends with a small primitive. The third problem is that bulging occurs when objects blend. The fourth problem concerns unexpected topological changes that we show later. On the left is a graph of the field function defined by the composition of f1 and f2. The white line is the ISO value used to visualize the model seen on the right. Our operator has a smooth contour generating a smooth blend. It allows control over the blending so that as the parameter is varied, the blend smoothly changes to become a clean union of the 2 objects. We can combine 2 primitives using a gradient-based function, which we call a controller h. In the graph, alpha is the angle between the gradients of the primitives. When h equals 0, we get blending, and when h equals pi/4, we get a clean union. For example, the unwanted bulging problem can be solved by applying a clean union where the angle alpha between the gradients equals 0. This is achieved by setting the controller h of 0 to pi/4. The result on the right also shows that small details are no longer blurred. Now the blending at a distance problem is solved by applying a clean union when alpha equals pi. By setting parameters, we get a family of controllers. This specific controller we call the Camel Controller, which solves all the problems posed at the beginning of the video. We have a bulge-free result, no blending at a distance, and small details are preserved. Note that when the user moves the blue cylinder to create a handle, the Camel Controller prevents the hole being filled. When we use the standard blending function, then the bulges return and the hole disappears. This is the topological problem we referred to earlier. The Camel Controller solves the problem. Here we see the effect of blurring when there is blending at a distance using standard blending. Again, our Camel Controller solves the problem. By varying the parameters of the controller, various blending effects can be achieved. For example, we can include both smooth blending and sharp edges in the junction between 2 objects. At the extreme, a sharp transition can be modified using the controller. The controller can also be used to parameterize different composition operators. For example, the contact controller associated with the bulging contact operator produces a bulge where 2 primitives overlap. We can smoothly change one controller to another by modifying the parameters over time to create interesting shape changes to the blend volume in animation. In this case, 2 groups of point primitives approach each other. The blend used is due to the Camel Controller, which prevents blending at a distance. When the objects come into contact, the parameters are smoothly changed to produce a standard blend, so that when the objects separate, they bulge toward each other.
This example illustrates the problem of the use of the Camel function to control a blend at a gradient discontinuity, where there is a sharp edge. When the objects are close, an unwanted handle is generated, and when they intersect, the transition exhibits a hollow. By simply changing one parameter before contact and a second in contact, the controller can be set to 3 key positions. We can then interpolate these parameters during the animation in order to produce a smooth transition in a contact situation.
The lava lamp example illustrates several blending operators and controllers. First, we see the bulging contact operator and, leaving the pool, standard blending. As objects fall into the pool, the union operator is used. Organic shapes, such as characters and animals, have some smooth parts and some sharp creases. To facilitate the design of these shapes, we set up a specific controller, the organic controller. Two surfaces smoothly blend where they have approximately the same gradient, while they join with clean union, forming sharp creases where their gradients are approximately in opposite directions. There is a smooth non-linear interpolation between these extremes. The examples designed with our interactive modeling system show the shapes that this controller generates, including fine details that are not blurred.